So the next example is the Radix Sort. Radix Sort is kind of similar to the counting sort, but it uses a little different numeric property than the counting sort. Here, the assumption is that the sequence only contains the integer values. Previously, the counting sorting made one more assumption here. That assumption was what? The range assumptions starts from 0 to k, right? However, that assumption is gone, is removed in this Radix sort. So sorting actually happens, how it works looks like this. So we have 170, 45, 75, 90, 2, 24, 800, 802, and 66 here. For your information, I'm going to make it all of these as 3-digit numbers. How to do that is 170, 045, 075, 090, 002, 024, 802, and 066. And then what happens next is that we are going to just look at the lower decimal values, lowest decimal values, the first decimal values. That's 0, that's 5, that's 5, that's 0, 2, 4, 2, 6. And what we are going to do is sorting based only upon this last digit, the first digit. And because these are all zeros, so 170 actually comes here first because we are only looking at the first digit. 090 comes here. Do we have any zeros any further? No. Do we have any ones? No. So the 2 is smaller, so 2 comes here. And then, yeah, 802, 2 is another thing. 2 comes here. And then, nope. And we are looking for 3. We don't have 3. We are looking for 4. Yeah, we won't have 1 4 here. And then 5. Yes, we have 2 5 here. So it comes right here. It comes to here. And then 6. That's all. So based upon the first digits, we have this sequence. And after that, what we are going to do is the sorting based upon the second digit. We are going to add 0, 0, 0, 2, add 0, add 0, add 0, add 0. The second digit is 7, 9, 0, 0, 2, 4, 7, and 6. I'm going to write down 7, 9, 0, 0, 2, 4, 7, and 6, right? And then what we are going to do is that based upon the second digit, we are going to sort. And only by looking at the second digit. So here, 002 and 802 are the smallest ones, so it comes here, it comes here. And the smallest value next is 2, it comes here, and smallest value is 4, so it comes to here, and the smallest value is 6, so it comes to here, and then smallest value is 7 and 7. So 7 comes here, and 7 comes here. And the last value is 9. Right. And finally, I'm going to add 0 here. We are going to look at the third digit. Third digit is here, 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 then like this. And what we have is 0, 8, 0, 0, 0, 1, 0, 0. And then because these are all zeros, so it just comes to the first by only looking, we are sorting by only looking at the third digit. Comes here, and 0 comes here, and 0 comes here. And then the 1 is here, so it comes here. And then 8 is here, so 8 comes here. So what we have is 2, 2, 4, 4, 5, 6, 6, 7, 5, 9, 0, 1, 7, 0, and 802. These are all sorted. Interesting, right? And actually, you have to look into further to find out how it works. Here, the thing is that what we are doing is that we sort these numbers based upon the decimal digits, right? Let's imagine that 2 and 90 are compared. Of course, 90 is bigger. However, the first digit side, 0 is smaller and 2 is bigger. However, what dominating is the upper values, the second digit. So that's why we are putting the inequalities like this, right? And actually what we do is that we are moving to the higher digit. And we apply this rationale. The higher digit number, if the higher digit number is bigger, then the value is bigger, even though the lower digit might be smaller. We are using that principle in this sorting algorithm. So basic idea is that we are going to have a iteration loop from the first digit to the nth digit. So that's going to be like this. And then what we are going to do is that we are going to sort. We are going to sort, put these numbers as the digits that we observed. So because that we have only 0 to 9 values for each digit, what we can do is we can prepare a small array. Bucket list means that small array, and put these values in the order. For example, we have a bucket 0, and bucket 1, bucket 2, and bucket 3, like this. And then we put like if we are looking at the first digit, 170 has the 0 value, right? So we are going to add 170. 170 and 45 here, and 75 and 90 and 2 and 24, 802 and 66. And after putting these buckets, so we are just moving iterations from here to like this, and adding these numbers into buckets. Then what we are going to do is to construct a sequence. This is construct of the sequence by putting at 170, 90, 2, and 802, 24, 45, 75, 66, like this. So this takes actually n times, and this also actually takes the n times. So this whole operation will take the order of n, and then this, again, the whole operation together is going to be order of what? Order of nd. So the time complexity becomes order of nd. Then what we have is order of nd. And why it is equal to the order of n? Because d is already kind of given. So if we have a range in values here, then D number D is already limited. And also further, this number D actually grows, covers exponentially. So if we have D equal 1, then we are covering 1 to 10. D equal 2, we are covering 1 to 100. D 3, we are covering 1 to 1,000. Only increasing two values, we are increasing range from 1 to 10 to 1 to 1,000. Let's imagine D is 10. Then 10 by 10, this is unimaginable numbers. So it's only increasing small numbers, we can cover whole or lot range. So these, the growth of D with a given range of values is very limited. On the other hand, N can grow any possible numbers, right? So D is almost going to the constant, and the N is the actual variable. So by multiplying constant and variable, what we are going to have is the order of N. So this is the implementation of the Radix Sort. First, we have the random number generation for the test, and then we find the digit numbers, how many digits that we have to do the iterations. And then what we are going to do is the placing the values into bucket and the printing the partially sorted values. And we are going to do the iterations for whole this time by the digit numbers. So that's the digit number loop, and placing buckets, that's the order of N, that's the D iterations, so this is going to be order of N D, and this is order of N iterations, right? And then D is very limited, so this is almost similar to the order of N. So we are claiming that is order of N sorting. So performance of the sorting algorithms varies. Really is there are various range of the performance. In the real world actual coding, many people do not concern time complexity of the sorting so much. People actually rely on database to the descending order, ascending order queries. So most of the time, people do not give too much thoughts on this issue. However, actually, you have to know the core of this operation, the time complexity, so that you can compare, you can consider the cost of your system in terms of the development as well as the maintenance cost. So selection sort starts from the order of n squared logic. So that's the order of n squared the sorting. That easy to implement, however, is worst performance. These are divide and conquer based approach and tree based approach. That's the order of n log n logic. Mostly recursion is the key in these logics. Here, that's up to this part is the comparison based sorting. This is more like numeric property based sorting. So mostly people use counting or digit value comparisons and other things. That's the order of n sorting algorithms. We have these various types of the time complexity, and so what you want to do is studying these sorting algorithms. So this is the further reading, And this is a great book, so please go home and read it. And also we have a bunch of the programming tasks in this lecture slides, so I recommend you to do that. Thanks for listening, and I'm going to see you in the offline session.